What if I told you Albert Einstein made a mistake over a century ago? And a professor just corrected it, rewriting a fundamental law of physics? Let's rewind to the early 1900s, when scientists were racing to understand absolute zero. That's minus 273 degrees Celsius, the coldest anything can possibly get. In 1905, a brilliant chemist named Walther Nernst noticed something weird happening down there. He found that as you get super cold entropy exchanges, basically the transfer of disorder, grind to a halt. To explain this, Nernst formally stated his theorem in 1912. He argued that because of this, absolute zero must be physically unreachable. He reasoned that if you could reach it, you could build a perfect engine that turns all heat into work. This would break a golden rule of the universe, the second law of thermodynamics, which says disorder always increases. But then, Albert Einstein stepped in and said, "Not so fast." Einstein argued that Nernst's perfect engine was physically impossible to build anyway. So he said it posed no real threat to the second law. He separated Nernst's idea and classified it as a brand new independent rule, the third principle of thermodynamics. And for 120 years, that's exactly what the textbooks have said. Until now. Enter Professor José María Martín-Olalla from the University of Seville. In a new paper, he takes a fresh look at that century-old debate. He says Nernst and Einstein both missed one crucial, subtle point. What if Nernst's engine is supposed to be impossible? Martín-Olalla reframes it as a virtual engine. It's a machine that doesn't consume any heat or produce any work. It's purely conceptual. Think of it like a placeholder in an equation, a tool for thinking, not a blueprint for building. He demonstrates that the formal math of the second law actually requires this virtual engine to exist. And once you accept that, two things happen automatically. First, Nernst's theorem that entropy exchange stops at zero falls right into place. And second, it proves that absolute zero is fundamentally inaccessible. Both ideas flow directly from the second law. No third principle needed. So the third law isn't a separate law at all. It's just a direct consequence of the second. Martín-Olalla even says another part of the old law is more like an important appendix than a new principle. His paper, published in the European Physical Journal Plus, just took a 120-year-old problem and showed how one clever change in perspective can elegantly unify the laws of our universe. If you like what you see, hit that like button and subscribe for more.